What's up? Wait, do I have audio? Yeah, alright. Alright, yesterday I implemented like a read file system call. Um, okay, so read file system call so that I can like read files from user space. So today I was thinking of implementing like the write system call. So you can write files from user space, but sorry, I got a hair in my tongue, that's gross. It's not very useful right now because I need to figure out like actual usage patterns, I guess, because right now, right, we have a shell, you type commands into it. And so yesterday I did read file. Even that's bizarre because like it's like reading and printing the entire file out. And like what are you gonna do? Say write file and then just write a bunch of shit here, like the whole file. Right? It's like for it to be useful, you need like a way to interact with files and stuff. But I don't know what I should do first, like make some kind of like editor. Probably not. There's also the problem of like, I don't know how to manage memory for files. Right now the way it's working is when you boot to the operating system, one of the first things it does is initialize the file system, and that is basically just reading all of the metadata about files from the like hardware, which in this case is like virtualized hardware. But so you're gonna read like here are all the files, and right now we're reading all the file data into memory when you initialize the file system. But in a real operating system, obviously all of the data is going to stay on disk until you need it. I mean, there's caching and stuff, but it's sort of like a on-demand. At least I'm thinking that's the way it should work. So you need some way of like, perhaps when a read file system call happens, is the point at which you actually read the data from the hardware into memory. So, I don't know, I got a lot of shit to do. I don't really know what I want to work on today, and I'm also super fucking tired, so I don't know. What should I do? Maybe we'll do the write sys call. Oh yeah, so I need backspace in the shell. That's actually kind of be really useful. Like, oh look, I misspelled text. I need a backspace. I can't. So like this whole command is now fucked. Like anytime you do a typo, the whole command is now fucked. So I need backspace. Maybe we'll just do that. That should be kind of easy. I'm gonna start with that. Okay. Let's do backspace. So in the shell, yeah, we even have a to do for it. So currently in the shell, what's happening? We have like a buffer, and you're just reading characters until it's a new line. Which I guess Kimu recognizes carriage return as the new line. So what we need to do here is identify backspaces. So we'll just, yeah. So what I'm trying to do here is reset like the cursor in the command line buffer right here. But the problem is, even if I do this, like you've still printed the characters to the console, so you need to like clear the ones that you've written. Well, it's backspace is one character, so you need to clear one character and move the cursor back. What I don't know how to do is move the cursor back. Like I know, like if I were to send a carriage return character, that would, I think, put it back to the beginning. We just need to go back one. What does that look like? Let me search. Here's XV6. That's like a educational operating system. We could see what they do, maybe. Console. They have console.c. Here, let me pull this over here so you can see it. This is tiny. It's probably fucking tiny. So backspace. They put \B. What does this do? Wait, this is what we're doing, the same sort of thing. You're like spinning until the register. I wonder if this is where Nuta or Seiya Nuta found inspiration for how he's handling it too. Because right now we're not like using interrupts for like waiting for a device to do its shit. We're just spinning until it's done. But anyway, it looks like they're just sending a \B character. So let's see if we could do that. So if we put a... So that should move back. So if this is the buffer, right, and the cursor is like going to be the next slot. If we move the cursor back one, we'll be here. This I-2 ensures that that's where the cursor's at in the buffer, because you have this, you increment after every iteration, right? So when you hit the continue, it's going to increment again. So this -2 is accounting for that. So you need to clear this character because we've already printed it. So I guess you need to put what? I guess a 0 there instead. Or a space? No, it's gotta be 0. A null byte. Right, but once you do that, you're gonna advance again. So you do another one? I'm thinking this. So this will clear like the on-screen printed characters. And then this will reset our notion of a cursor. And then we just wait for more input. I think. Let's see what that does. Yep. What's weird? Oh, I thought the cursor disappeared. Cool. Oh shit. I deleted the prompt. We should probably... And... It didn't clear the buffer, I guess? Wait, what? Wait, what? Oh, because we're not okay, I know what's happening. We're writing zeros like to the Alright, so we have two diverging representations of the same information. There's like what information we send to the actual like console, which is these put chars, and then there's like our own representation, which is the command line. So you need to do like command line. The previous one is 0. Yeah. Uh-huh. Empty. Okay. But we can still delete the prompt. So, you can only backspace if I is greater than 0, right? Huh? Well, hold on, because if it's 1, you'll go -2, which puts you at -1, and then you'll hit the plus plus, which will make you 0. So that's fine, as long as this is assigned value. Okay. It's still deleting the prompt, though. Interesting. There's no warnings for there. So, right here, I0, for sure. We press backspace. What's happened? I guess now we think I is now 1? Is that what's happening? Yeah, because this, I guess, always needs to happen. Anytime you press backspace, I needs to be reset, for sure. If it's greater than 0, then you do minus equal 2. If it is 0, I mean, we could set it to -1 so that the increment puts it back to 0. Cool. That kind of works. Seems kind of jank, but it works, so we'll go with that for now. Cool, we got backspace. Quick win in the morning. Let's go. Morning being 5 p.m. What's up? Alright, so should we do like a write system call? I feel like I want to figure out a better way to handle memory for files. I guess we can... Cool. So let's look at file system init. So currently, read the entire disk into memory. Parse them into files. What I think should happen is you should read all the metadata about files and have an in-memory structure. Like the file system is a structure of all the file metadata. Question is, at what point do you need to actually allocate the file? Like the content of the memory. Should it be at the read file call? Handle syscall read file.
No matter what, you keep finding something to fight for. Now, I know that's not what you wanted to hear.
Swear to me. Swear to me that everything that you said about the Fireflies is true.
One of the things I was thinking about yesterday is having a flag in the file struct. Is this file loaded? And
Okay.
if not, then at that point, so in here when you're finding file by name, you would search and say, all right, once we find it, we'll say, hey, is it loaded? If it is, just return it. If it's not loaded, then at that point we'll allocate space for it. And all I have right now is page allocator, so the other question is like how to handle like editing files, like not like from the editor perspective, but like a file has a size when you read it, but you can append a bunch of data to it, growing the file. So what I'm thinking is like you could just have like chains of pages. It's just How do you really stitch all that stuff together? Right, also interesting. The way we've implemented writefile is like user space provides the buffer to read it into. So you're just allocating on the kernel side, which we don't have to do if you're reading it. I just don't even know what to do. I think very tired today. So I could work on this. We need more form, like we could expand out the printf implementation because right now it's a piece of shit. My printf, currently I support %d, so you can print integers, %x, which does a hexadecimal print of a unsigned of a U32. C, you can print characters. S, you can print strings, and you can escape % with the double % to get a literal %. The issue I've hit is a lot of times just wanting to print instead of hex for U32s, I want a decimal U32. So we could do %u. And then like there was one time I wanted to do U64. It's a 32-bit operating system, so like we're using RISC-V 32-bit. So I don't encounter U64s a lot, but there was one register that had it, so I need to print those. All the things. It's probably, we could bang out %u pretty quick. It's basically the same as this. It's %u It's gonna be a U32. Can never be negative. Interesting. So divisor here. Oh, that's fine. That's fine. Is it literally just switching to using this? And then I feel like that should work. Alright, we'll have a val, which is... What should I do here? Like... What is that? It's 1, 2, 3 bytes. 4 bytes. Something like that. What? What's happened? We've infinite looped, so we're probably in here, right? So what am I doing here wrong? Pull the value out. Yeah, divisor's starting at 1, right? And then you're trying to find the largest divisor so that you can do this without having to reverse it. You know, you can do it in order instead of in reverse order. All divisors greater than 0. So your divisor should reach 0, right? How do you debug printf in a kernel? You have no debugger and no printf to debug the printf. You can just put char, I guess. What's the fucking divisor? First of all, can we just see if we're in here? Ah, okay. We should probably do this after the trap handler, I guess, maybe. No, that's not the problem. It's weird. The fuck? We could be in this loop. It's gotta be alright. We are, okay. So why are we not, the wild, divisor times 10. Is it because this is getting cast to like a double or some bullshit like that? Hold on a second. What if we make this like that? It's not that. So no matter what that is, this is going to reach 0. Why does it not? I suppose you can still use printf actually. It's just gonna be garbage because it's gonna go to negative. So like the divisor gets fucking enormous. Confused about why this is not like reaching 0. Am I stupid? Am I fucking stupid? Is it an overflow? Is that the problem? It's because of that. That's insanity. Okay. I see. So, yeah, I think what's happening is we're overflowing. So I guess we just need to have another check in here, so. Which suggests that we have the same bug in D, because if that overflows integer, alright, so we can fix both of those. So we're checking the next, like, basically decimal place, seeing if that, you know, you want to find the largest divisor. So I mean, one thing you could do is just hard code a divisor max, because you know that for each. We could also just check if, like, if divisor is less than the max value and divisor times 10, wait, no, if you're saying, actually, if divisor times 10 is less than divisor, you've overflowed. Okay. So while that's true, we do that. Okay. Let's check that. That don't seem right. So this is the number we're talking about. So we're trying to find basically this number. So we just want to find 1,000,000,000, right? I'm not seeing why this doesn't work. Oh, I'm not in. God damn it. How the fuck is the divisor this? What the fuck are you on about? Alright, so that's when we get our value. I don't get it, so how are we overflowing? The fuck is happening? This doesn't make sense. Alright, so you reach this value, right? You reach 1 billion. The next will be 10 billion, which is too big. So like, alright, the divisor is currently 1 billion. Divisor times 10. 10 billion. Overflows is smaller. This is now less than divisor. This doesn't happen. Divisor's still 1 billion. What the fuck? I don't get it. Something's wrong. Like, I'm obviously thinking about this wrong. Right? Divisor is 1 billion. Divisor times 10 overflows. Why the fuck is it doing it? Am I stupid? I'm so confused. This is so insane. Alright, I'm just so fucking... I must be tired today. So let's do something fucking annoying. I don't need anything. Um. So how you do it? I always fucking forget how to type this. Like which direction is it? Yep, that's right. So we do need to include, what is it? Types, C-type maybe? I don't know. Student, right. Alright. What value were we using? Let's use this one. That's our value, that's our divisor. Yeah, we need this whole fucking thing. Okay. Okay. Alright, let's fucking go. Show me the valve, show me the divisor. Alright, so it's, and show me. So how many zeros? Seven, 8, that's 9 zeros. It doesn't know my types, does it? It doesn't. Does it know UN32? It does. Okay. What the fuck? Does it mean that it wraps around so fucking far that... What the fuck? This is so insane to me. Guess we just fucking hard code it. What the fuck ever. I think what's happening is like a billion times 10 gives you 10 billion, which wraps around to a value that's still bigger than a billion, which is frustrating. So I just am not good at detecting overflow. I'm just dumb, I guess. Like, yeah. That should work though. Still not right, I don't think. Yeah, there we go. Yep. Fucking hate this shit. Yeah. So what's it gonna be for signed integers? Still a billion, right? Yeah, because max signed signed integer 32-bit is 2 billion something. I guess we'll put that in a constant. Wait, what? I already fucking did that over here? Wait. It's like the same. I've already encountered and solved this problem and my brain just doesn't remember at all. Okay. It's a real struggle today. It's a real struggle. Should we do a simple write? I think I don't have it in me to do any type of restructuring of the memory management stuff, so I think I could just slap in the write, what's this called? I just don't know how to use it. So hold on, user space. Well, first of all, format specifier. So I guess we'll do a write file syscall, which what's the interface? Like, what's the prototype for this function? Obviously, you need the file name. Do you just have the buffer that you write to the file then? Write all of this shit. That makes sense to me, actually. So over here, let's make a write file. So you can just return how many bytes. Hold up. Wait a minute. Okay. So in the kernel syscall, handle syscall, we now need a honestly like almost the same thing. So when you write a file, oops, pull out the same parameters. Default 0 bytes written. Say, hey, the supervisor should have access to user memory right here. Which is the buffer passed in right here. Find the file. If you found it and it's in use, So here the question is like, should you be able to write to files that don't exist? Do you create a new file? How does that work? I guess for now we can say you can only write to files that already exist. This time if it's greater, because currently currently you're writing the file data lives in the like disk, meaning like the variable we call disk, an array of bytes in memory, is where the data for files lives. Our file struct has just a pointer to that. So the size is set by whatever its initial size was. If you write past that, you're overriding the next tar header. So for now we have to say, hey, you can only stay within that size. I mean, should we say error here? Error, read file. Right here, actually. Yeah. Check it out. All right, these %x's. All of these, we actually wanted to print like decimal values, but we didn't have that yet. For the magic, I'm not sure. I kind of feel like hex is fine with that, but U32 of this. Addresses are fine. Buffer. That's pointer, so that's fine. Ooh. I guess having like a pointer specifier might be good, then you can just pass any void star in there. With length U, not big enough for file S with size U. Bufflam. File size. Okay. So file and size lam. But try to write buffer boom with length that. So it's like this. So file name has size this. Try to write to this buffer which has length this. Right. Otherwise, we can write into file data buffman. That's how much we wrote. Otherwise, file not found. Alright. Alright, so we have a writefile syscall now. Does this compile at all? Nope. Got a fucking semicolon. Alright. Now what? We add a so this is like terrible. This is not how you parse a command line, but this is just getting shit started. Alright, so now the question is, what's the interface here? I mean, I think I'm just gonna make it the dumbass thing that I said, like, you just have write file name, and then, like, the data here. Should we wrap it in quotes? Hoopla. I guess. You start at file name, and you say, alright, until you hit a space of any kind, which will include actually, now I'm confused why this worked before because, like, the fuck? How does that work? Because that's not necessarily, like, if you do read file, if you do that, right? Well, when you enter the command, you hit enter, so there's actually like a new line here, or carriage return something. And when you get this file name, you're just pointing to here and treating it like a null terminated string, I guess. Which and you pass that to read file? Right? I'm actually confused how that worked at all in the first place, because this third comp is gonna... Actually, I know why. It's because we handled... Hold on. The command line is initialized to 0. So when you write all these characters in... Well, you do put the new line in, so there is for sure... Wait. But that's not in the... You don't put the new line, you break before you write it. So we handle that. So thank you, thank you, thank you. Alright. So you've got the file name. Now we need to get the pointer to the data. So skip past the file name, skip past the spaces. We're gonna expect... See, I really need to write a proper parser, I feel like. Typically I'll have a little thing that's like, you know, you'll tokenize it and shit. You can expect this token. You can have an optional quote. Skip. I mean, since this is a really fucking dumb version anyway, let's just not even do quotes. This whole thing needs to be changed. This is just a proof of concept anyway, so We'll just say no quotes. You'll just go to the end of the thing, the end of the buffer. So now you have a pointer to the data. Bytes written. Write file. File name. Data. I guess we need a data length then. Well, then maybe we will do the quotes because I was trying to avoid having to do this. Do we have Sterling yet? We do? So I guess you can actually just do Sterling data. Right? So if it's equal, success, otherwise failure. Successfully. How the fuck do you spell successful? Only one F? Two Fs? One F. Yeah. Or, sorry, S's. Two S's. Successfully wrote this file. File name. Error, write file. Failed to write to lamb. Try to write this many bytes to this file. Only this many were written. Okay. Can we compile it all? Alright, let's just do this. What was the first one? It was like, hey bro, you did bytes. Oh, right, file. Alright, so presumably wait, I didn't do this yet, right? Um Yeah, so the problem now is that we're writing into our in-memory representation, which is the file, but we need to flush the disk. File system flush is not getting called. So maybe when you exit from the shell, that's when it does the flush. Call exit, it flushes, and then exits. And this is kernel space code, so we can't call that here. Damn it. Well, it's called, yeah, we need to handle that in like the syscall, so. If it's exit, what do we do? Well, you exit this. This is only one process. When one process exits, you don't want to flush the file system. Then we just want to flush it at the end. So right now our concept of end is only like when you reach the idle process. So I suppose you can do that here. We flush here. This doesn't seem right either, but it'll work for now. Okay, so if we read file, I love that we have backspace now. This is what's in there. If we write in there, some random stuff. We didn't drop in a, yeah. File not found? Why did the write even attempt to happen? The file's not found. What the fuck? Tried to write 19 bytes to this, only 0 were written. What the fuck? So, first thing that hits is file not found, right? So that's here. So it totally hit this. And then it's hitting this? So calling it multiple times? I don't know. Maybe if once we fix this will go away. So at this point, it is a space. You can do this. Null terminate file name. Oops. Successfully wrote fof.text. If we exit, that should have flushed the file system. So now, if we look at this tar, if we edit our run to not rebuild the system, it's the wrong size. Some random shit. Because we didn't add a... Okay, so it did right, but we didn't add a null terminator there either. Also, writing this file should change the file well, you need to change the files, like the new size is buffland. Do you include the null terminator in as part of the data? I feel like, I don't know. I'm gonna say no. This is unused right now. Alright, so we just need to change the size. So this time I do want to build it. Hey, that's that. If we write some random ass shit. We wrote, we exit to flush. No, don't build it. We've redone the thingy. The problem is the other file disappeared. Why did the other file disappear? Or is it because... Oh my god. I don't know how much longer I'm gonna last. Okay, why did the other file disappear? Let's look at file system flush. Write all files to disk. For every file in use, you know. We write the stuff out, we run a checksum. We're doing a straight mem copy of the header and then the data. Sure. Right in memory disk out to the block device. So I don't understand why. When you flush the file system, suddenly the second file goes away. I mean, my guess is it has something to do with dropping in a null byte. Like, when you write maybe it's like when you truncate a file, it's dropping a null byte at the end, and so now somehow that's fucking up the write. But I don't see any place where that matters here, because we're just basically using memcopy. We're not doing like a stir copy or something. It's just, hey, here's the size of a header, write all that out. Great. For the data, you're just explicitly telling it how many bytes to write. It should hit both of these. I mean, you could say flushing file this. Does it not ever hit that? I don't fucking know. Yeah, build it again. Unknown identifier. Path name. The fuck? Oh, right. We flush FLF, we flush Jabberwocky. Okay, so if we open this up in a hex editor, Jesus, fuck that. Okay, this is a disk. Why is this all blue? What the fuck? FLF. The contents is just these. You have Jabberwocky still, and the contents the same. So we wrote it out. Fine. Wait, why is it there twice? Jabberwocky.text here. This must be the old one? What? So we're reusing the... We're reusing the buffer for the disk. for reading and writing. So like, so write an in-memory disk out to the verge. Yeah. Interesting. So we should be using this though. Like one option is to zero out the disk before we write the um, but actually we can't do that because um like the disk buffer is literally what owns the file data right now. So we're gonna go through all the files. If the file's in use, then create a tar header, write the tar header out. Then what? Copy the file data, which is like the most recent version, into there. I guess it doesn't truncate the file when you do like a sector write. Yeah, so all of this logic is sound, I believe. It's just that write sector, which goes in here. Like, yeah, whatever was still in the file remains there, so I guess the only way is when you flush the file system to do this, fill the rest with zeros. I don't want to do that, because then you're gonna end up with the same disk file with a bunch of zeros. We need some way to, like, when you write out to the VirtIO block device, to like be able to truncate the file that you write out to, I guess. Alright, for now we're just doing zeros. Which means we need to keep track of this. So sector 0. Verta block sectors. This is bozo, but that's what we're gonna do. The fuck? Now I'm super fucking confused because all we did was edit flush and now initializing is fucked. What? What? So it's reading this as the magic now? Like what? That's cool. Vim recognizes star. And you can read from it. That's kind of cool. I don't understand. So what the fuck's going on? Oh, what the fuck? Somehow I deleted this line randomly? Wow, it's weird. Okay. Alright, we got this. If we write some randomy stuff and things. We wrote it. We flushed it. we read it back in now, we still only have one. What the fuck? The fuck? What the fuck? I'm just so confused now. Alright, rebuild this again. Maybe the problem's in reading. God damn it. Jesus. Yeah, I think that's part of the problem, is like you're not truncating the size. It's just reading all of that shit in. I mean, wouldn't this also be solved if you... Actually, no. What's the problem of... Um... 16 bytes? That's right. Interesting. Well, this write zeros is interesting because it suggests we could. Well, I mean, our situation is like a temporary thing anyway, but it suggests maybe you could. So I'm gonna waste all this space for zeros. You could just issue like a write zeros request. Which would, I guess, do this. So instead of black T outer in, it would be like this. Yeah. Interesting. I'm still confused. Ah, fuck! Wait, no, that should work. So 4 sectors were written by the time you flushed FLF and Jabberwocky, so Jabberwocky is like this many bytes. FOF is now like 4 fucking bytes. So it's less than 1,000 bytes for 4 sectors. 4 sectors honestly seems like too much. Well, no, because you need a tar header for each one, so it's about like a sector for each header and a sector for each file, I guess. Kind of makes sense. So you're gonna have 5 sectors worth of zeros, I guess. I really wish I could see this fucking... My trial of 010 editor ran out. So I need a fucking hex editor now. It's not... How much does this thing cost? Fuck, it's fucking... $150? God damn it. I would fucking buy it from you if it wasn't... The rest are filled with zeros. I guess the problem is perhaps that the headers have to be in separate sectors for sure. I'm confused because I've just confirmed that it's writing correctly. Like, you have both fucking files are there. I see them. But reading it is not seeing them. So why? Whew, man, I think I just need to sleep. Yeah, alright, what is this fucking thing? So... this is confusing. So... as we go through our in-memory representation of the disk... okay, because when we read it in... you just read it in a sector at a time, sure. And then we're parsing that into files. So you're actually parsing it into tar headers. Then the data. But then when you advance the pointer, why are you allowing it to sector size? Because all right, because when we wrote it out ourselves, does this make sure that when um, headers are on a fucking sector aligned? Sector. Aligned? There's nothing about alignment? The file data is written unaltered except that its length is rounded up to a multiple of 512 bytes. So maybe that'll fix it if I just... I guess... Okay. So here, we're assuming that the data is rounded up, but when we write it, we're not doing the same thing. So, yeah. So, let's do this. When you're writing to this, you're gonna copy... This needs to be aligned. Sorry, wait, hold up. The sector size. You do that, you copy all the data. The offset, it depends on this disk end. Okay. That should actually handle it, right? Well, no, because now you need to write zeros, I guess. So now I just need to memset the rest. Which should be what? Starting there, you're gonna write zeros. How many? Let's do this. So you take the align size minus how much was written. That gives you how much is remaining. That. I think that might work. Let's see. Now we got both files. One, two, three, four. And the Jabberwocky file. Okay. Well, we have a writefile sys command now. So that was it. It's because yeah, the file data is supposed to be aligned up to 512 bytes, which is sector size. I see. Ooh, that was a rough day. I'm gonna stop there because I'm dead, and glad to have made a little bit of progress, but I'm just getting frustrated and being stupid, so it's probably best if I just duck out. We don't need that. Clean up any other stuff from me. Do we have any more like debugging prints around? I think so. Hold on, let's make sure, yeah. Flushing file. Alright. Well, we did in fact make a right. What's this called? Alright. Well, that's it for me, I think. Peace.